Here I will introduce my paper titled NTR Gaussian Nighttime Dynamic Thermal Reconstruction with 4D Gaussian Splitting based on thermodynamics. The goal of this paper is to investigate how flow and night and characterize this variation using 4D Gaussian splitting. Methods usually only perform the thermal reconstruction under static conditions without considering changes in things temperature and are unable to dynamically represent and predict temperature variation in scene. Traditional thermal infrared simulation methods, which rely on manually built scenes, struggle to restore real and complex three-dimensional scene. Additionally, they fail to reflect the dynamic thermal radiation changes in scene. We constructed the NTR dataset specifically for the nighttime dynamical thermal reconstruction. We propose the NTR Gauss, which can learn the emissivity, convective heat transfer coefficient, and heat capacity to predict the surface temperature of outdoor scenes at night. We use networks and integrate strategies to solve differential equations and improve the accuracy of temperature prediction. Extensive experiments have demonstrated the superiority of our methods. The network consists of three parts. They respectively predict the emissivity, convective heat transfer coefficient, and heat capacity of the target, which are heat capacity is related to object positions, hence requiring input position encoding. Our NTR Gauss outperforms other approaches in quantitative metrics, achieving a predicted temperature error within 1 degree Celsius. It can be observed that our method produces more accurate temperature predictions. It is important to note that the relatively small difference between the metrics of static and dynamic methods stems from the fact that static methods learn the average behavior over a certain period. As a result, static methods may perform better at specific moments but worse at others. Our approach is based on thermodynamics principles and can simultaneously deduce the relative magnitudes of physical quantities such as emissivity, convective heat transfer coefficient, and heat capacity, thereby calculating the temperature map mentioned in the paper. We present the NTR Gauss as a novel approach to overcoming the limitations of existing static thermal 4D reconstruction by incorporating dynamic environmental factors and temporal informations. Our NTR Gauss outperforms other approaches in qualitative metrics, achieving a predicted temperature error with 1 degree Celsius. Thank you.